This video goes over solutions to exam 4. So in the first problem we have interconnection of inductors. So we have terminal A, 25 millihenry. Make sure that looks inductor-ish. Then we have 3 inductors in parallel. Here's A, here's B, and then there's a 10 millihenry here. This is 60 millihenries, 20 millihenries, and 30 millihenries. So if we take 60 in parallel with 30, we get 20. And then if we take 20 in parallel with 20, we get 10. So that would then put 25 millihenries in series with the 10. And then you still have this 10 millihenry up the top. So that then puts 10 millihenries in parallel with the series equivalent of the 25 and the 10, so in parallel with 35. And if you do that calculation, you get 350 over 45, which ends up being 7.8 millihenries. And I asked you on this question not to put units. That makes it a little easier. Okay, question 2 is same thing, except it is a capacitor problem. And you remember that capacitors combine opposite from resistors. So if they're in parallel, they add. If they're in series, they combine as inverses. So here is the question. We have 4 farads. 12 farads, 6 farads, 3 farads, and 4 farads. So the first thing to obviously do is to combine the 30 and the 60 in parallel, or the 3 and the 6, and they add, so we'll get 9. Then you have 4. And then the 4 and the 12 in series combine as inverses. So it'll be product over sum, which is 3 farads. We then have the 3 and the 9 in parallel. So we just add those to get 12. And the 4 is in series with the 12, so once again, that's similar to what we had up here in this portion, this step right here. So once again, 4 in series with 12 is 4 times 12 over 4 plus 12, which is going to be 3 farads. So the answer is 3. Hard on these two because it was so straightforward just to do series parallel combinations. Hard to give extra credit at this point. You should know how to do series parallel. Okay, then on question 3, you have a 40 microfarad capacitor. It is initially charged to 120 volts, and then it loses some charge. It discharges down to 80 volts, and the question is how much energy was lost. So we use our 1/2 CV squared formula to find out the initial energy. It'll be 1/2 times 40, 10 to the minus 6, times the voltage, 120 squared. And then at 80 volts, we have 1/2 times 40 times 10 to the minus 6 times 80 squared. And so the change in energy is just going to be the difference. So it'll be 1/2 40, 10 to the minus 6 120 squared minus 80 squared. And let me do that for you really quick on a calculator. So 120 squared, calculator real quick, 120 times 120 is 14,400. So this term gives you 20 times 10 to the minus 6, 14,4, and 80 squared, 6,400. And so times 20 so if we do that we get 160,000. Yeah, which is going to be 0.16 joules. Okay, I need to double check that answer because something seems a little off there, but I think we're good. Okay, question number 4. The current in a 10 millihenry inductor, so L is 10 times 10 to the minus 3 henries. The current I of t is 6e to the minus 3t amps, and you're asked to find the voltage. So this is super simple. V is L di dt. So it's 10 to the minus third times minus 3 times 6 e to the minus 3t. So let's see, that's minus 30 times 6, so minus 180, 10 to the minus 3, e to the minus 3t. Let's check that. That's 18 times 10. Got the negative sign, so we're good. So it's 0.18 e to the minus 3t volts, doing L di dt.